Thanks so much, Domi and Rob. Awesome job emceeing so far. Welcome everyone to GitOps Unlocking Cloud to HashiCorp Digital 2020. Absolutely amazing to be here. So to just get started, a little bit about myself and my kind of background. So I'm currently working as a principal technologist at Lab 3 in Melbourne, Australia, and lucky enough to be a HashiCorp ambassador, one of 3 in Australia, in the open source community, and looking forward to seeing what we can do for the first year of that program this year, which is absolutely amazing. My experience with Terraform and kind of my GitOps journey was lucky enough to be part of the first production implementation of Terraform Enterprise in the Australian biggest 50 companies, which was an amazing experience to be a part of. But enough about me, kind of why we're here to get started and stuck into GitOps. So how do we get to GitOps? Well, the question I see more often than not is, why do we need all these tools and technologies, and why is cloud so hard? There's a famous comic that Dilbert has written that really does hit real close to home for me. And there's a couple of characters in this comic that we see. We have an architect and an executive. The architect saying, why the executive saying, why hasn't cloud fixed all of our problems? The architect comes back and says, well, you didn't let me re-architect that to be cloud native. The executive, trying to sound like he knows what's going on, just responds with, just put it in containers. The architect comes back and says, you can't just say tech things and think it solves our problems. And the exec just responds with Kubernetes. And that hurts. And going off what the Nomad session just had, there's this preconceived notion that going to these technologies solves all of our problems. But the main 3 challenges we face around cloud really revolve around traditional IT versus cloud native IT. And I'll look to cover a little bit of that in the next kind of couple of slides. But a big one is the change of culture. And really the transition from those models and how we progress past those. And there's this triangle of discussion that's constant in cloud adoption, which is the speed versus risk versus cost discussion. And we'll cover a bit of that in a responsibility model that I've drawn up. But how do we solve these problems? Well, as you may have guessed, GitOps is how I answer that question. And I have my own definition of GitOps. Weaveworks did coin the term, and accredited with coming up with a term in terms of managing Kubernetes clusters and application deployments to those clusters. But I think based on the maturity we now have around cloud and some of the HashiCorp stack, we can now move past that and say that GitOps is really using Git as the source of truth for the management and the deployment of our cloud native technologies, which is really exciting. But before we dive right into some of the Terraform aspects of it, what is GitOps? It's another ops word that we're hearing again, and it really comes from this rubric here, this challenge of, we've come from a traditional IT background where we have ITIL as our kind of main system of operating, which is really people managing systems. It's a very spoken way of operating, and it's very risk adverse for a good reason. We have a central data center. We don't want things to go wrong there. It's very expensive when things go wrong, and we're trying to move to this cloud native world where we have GitOps, people managing code managing systems, and this whole new way of working, which can be really scary. But we don't need to necessarily throw away all of those ITIL practices, but we need to put them into code so that we get the best of both worlds. And what we start to see as we go through this kind of transition into this GitOps model is we move away from the traditional heavy monolithic-based application and shared service, and we start to move towards the loosely coupled modules, which we all love, something that Terraform can really help us with. And what that ends up doing is it changed our attitude from a cost-driven enterprise in terms of traditional IT structures, and moves us towards something that's more inexpensive to change, open to innovation, and we've got scalability on our side in these cloud environments, which is super, super exciting. So how have I actually seen this kind of challenge solved before? Well, inner source isn't a new term. Tim O'Reilly actually coined it in the mid-2000s. It's defined as using open source software development practices, which hopefully we're all pretty aware of, and the establishment of those practices within organizations, specifically the culture of those within organizations. And Armin, who had an amazing keynote the other day, has a really great article and a video, in fact, on the HashiCorp resources page, which everyone should definitely go and watch. But he really tries to break down decentralizing the trunk of enterprise technology, which is super, super important. But essentially what we want to do is we want to feed off the middle branch. We want to enable teams to grow from a shared baseline rather than trying to plant a forest, as an example, and to stick with the analogy. And we want to do that through community-driven collaborative infrastructure as code. to start off with, and we need to get everyone involved. We want pull requests from security, we want pull requests from infrastructure, and we want pull requests from people managing cost reports if we can get them to do that as well. And I think once we start to get on that journey, we start to really see huge benefits in an organization with reusability, flexibility, and even a faster time to market for the delivery of some of our applications. I started to talk about that operating model, and I drew up this visualization when I didn't find a really clear way on the internet of illustrating the change between an ITIL traditional driven data center approach to one of a cloud native capability and the culture change that enterprises go through. So on the left-hand side here, we can see traditional IT, application teams looked after by apps, applications looked after by app teams, middleware is looked after the middleware team, infrastructure. It's very clear what everyone does, and everyone has a color that they align to. If we look to build an application in that traditional IT system, what we end up doing is asking networks for a network range. We ask for security for clearance. We ask the data team for access to the store. And we end up going through huge amounts of steps just to get to the deployment. And that can take weeks, maybe months. And that's traditionally done in an on-premise environment. What we start to see recently is the transition to hybrid IT. And we start to see this emergence of these DevOps teams. The infrastructure team starts to bleed into some of the other areas as well. We've got the data team conflicting with the app team because our app and data are tied together in cloud. And it's a real battle for control in terms of how we're operating. And we start to see the colors blur. And when we're grabbing for those territories, what that actually encourages is really deep coupling of responsibility, which isn't what we want. We want everyone to be open and sharing and really following those inner source models in terms of our GitOps approach. The challenge is when people move to this hybrid model, because of the ability to provision in cloud, we actually still see a decrease in time, but it's an illusion. That normally comes at the cost of risk and security posture of an organization, which can be extremely costly in the long run. And what we want to get to is start looking at the cloud native IT world, get everyone working in the same way, in the same color, if you will, through the same tool sets. And, for me, that really talks to the workflows and how we get everyone operating on the same page. So that's how I kind of define GitOps and what we have and how does this get solved? Well, Terraform, as I'm sure everyone aware of here, has a couple of offerings, Terraform Enterprise, Terraform Open Source, and Terraform Cloud. I'm really going to jump between Terraform and Terraform Enterprise really quickly in this. But essentially Terraform, infrastructure as code language driven by open source, declarative state management, over 200 providers now, which is crazy. The Domino's Pizza provider's already gotten a call out. Sentinel policies for no pineapple, I agree. But really, why do we use Terraform to solve some of these problems? Well, it's modular and reusable, which is an extremely beneficial thing in an organization. We want to scale, define once and use many. It's a very powerful thing that enables us to really speed through our development and our deployment activities surrounding infrastructure as code, and even using some of those other providers to extend past what we would call traditional infrastructure. It's extremely human readable. It's amazing to see security engineers sit down and look and break down Terraform and understand what's going on compared to some of the other services that are available to do the similar things. It's extendable. We touched on how many providers there are, how many other things we can use with it. And for me, that's the biggest selling point. To be able to go and provision a full CI/CD pipeline as well as my cloud deployments with the same language is extremely, extremely powerful. So how does Terraform Enterprise fit into that picture? Well, the collaborative infrastructure at code at scale is really where that comes. So the ability to start to use workspaces, get RBAC around those things and have people collaborate not just on local machines is amazing. And Terraform Cloud does a really good job of introducing those as well. Compliance, Sentinel, it gets introduced here, our policy as code framework where we can start to apply policy as code to our workspaces and our deployments and even have things like budgeting in there, which is amazing. In Terraform Enterprise, we really see the emergence of some of the security features of the platform. So SSO enabled on the web GUI, some audit logs and things like that. And also scale. We see some really amazing control around the Terraform worker node and how many runs we can do in a collaborative way in terms of how many parallel workloads we can run, which is, if you're running at a huge scale, extremely important. So we touch back on the kind of the ways of working, and Terraform really unlocks these workflows and not technology's mantra or Tao. And for me, it's really about the abstraction. So how do we actually work with getting those teams that are stuck in this trend within this model of trying to deploy their application? Well, we need them to operate on the idea rather than individual events. So for a GitHub repository, as an example, we want someone to deploy a repository. We don't want to have them to know to talk to the person in service desk and then the manager for approval and all of these different bits and pieces because all's delayed. We've done this hundreds of times. We want to make this as quick as possible and really get the benefit of that, which is really the economy of scale to the next point here. We want to make sure we're reaping the cost advantages benefits by doing these processes over and over again. And by defining these as code, hopefully we can start to get a one-to-many benefit to using these modules through Terraform and how we go about it. And these 3 points really, for me, are how GitOps starts to work about unlocking the value of cloud. We really start to see people contribute centrally to the benefit of each other in that inner source model. What you do have to be careful of is you have to think about how you're going to enable people to do certain things. So we can't just simply swing open the doors. And Sentinel's a really good way to manage policy around that, which we will touch on in a little bit as well. But what you might end up doing, as an example, this is a diagram that I'd thrown together in a previous role. But essentially what we look to do is we look to map the roles of that responsibility model across some of the resources we might have. So in Azure, for example, the main example I go to here is a subnet, which is a little bit hard to see, but forgive me. But we have 3 teams that care about subnet resources. We have security who care whether that's public facing. We have networks who care whether there's an overlapping range with another subnet or network address space. And the application team who care about just trying to get their app to talk to what it needs to and configure that. So when we move to cloud and we have this flexibility around resources and roles that people are trying to do, how do we look to solve those problems? And trying to define something like that is really quite complex. And so Terraform can help us do that by the creation of modules and getting everyone's input into it. And again, it comes back to touching on the workflows and not technologies piece of the puzzle. So in this example here, we talk about containers because everyone loves containers. This is the standard kind of set of resources we would need to deploy something, an application in Azure running on Azure Kubernetes service. So this isn't everything, but it's a nice list to kind of go through what we need. So at the top here, we can see we've got all of the different teams and resources that are needed to kind of configure all of this IP that we've collected over their experience. And what we can start to do with Terraform is look at breaking all of these into specific chunks and reusing those as much as possible. So for example, on the left, we need to start putting our code somewhere. So let's define with our DevOps team what a GitHub repo looks like for our organization. Then let's work with maybe a cloud operations team, if we have one of those, to look at the default management group and subscription constructs that we need. And the list keeps going. But as you can see, if we had to define this for our developer every time, there's a lot of reinvention that happens, and that really costs us time and effort, and from the business's point of view, money. And what we want to try to do is make sure we're reusing as many pieces as we can to Terraform's main benefit in terms of reusability and modularity. We want to reuse those things to enable our end user down the bottom to essentially say, let me grab all of those things and reap all of your hard work and get as far as I can as a success. So as an example of this, when we look at a GitHub repository as code, what does that look like? So, as a new developer, I need to get a repository to store my business logic. So right down the bottom, you can see here we've got a module that's asking for a new repository for our application. Within 5 lines of code, we're able to pull that module, in this case from our Terraform Enterprise private registry, and then we're able to take the construct of that module, which in this case has a default templated module with branch protection, default security teams added so we can scan against that code after it's built. But the developer doesn't get exposed to any of this. He's able to just reap the benefit of how many times we've done that before, which is really important. We're able to move much faster than we were previously. When we look at the classical infrastructure as code, as a dev or an engineer, I want to deploy the infrastructure I need. So how do we go through that? And again, we want to go and reuse a module that for this case is an application with an app service plan, VNet integration, logging enabled, all of those kind of things, so that we can look to enable the developer as fast as possible. I have a whole other talk on Terraform at scale, which talks a lot around some of the conversations that happened in HashiDays 2017 as a bit of a throwback around Terra liths and Terra mods and Terra services that I really encourage you to check out, because some of those resources in there are really, really amazing. One that a lot of people seem to steer away from is networks as code. And especially in the DevOps world, people seem to not want to touch networks as much. And I think that there's a real advantage to have, and Terraform can play a really massive, massive part in how we look about going through this. So as in this example, a previous module that I've worked on, we had an IPAM integrated into our module, which would just call for an API address to get the next available subnet that was available to us through their IPAM. And what that did was that it enabled the network engineers to not check, and hopefully not their spreadsheet with all of their free IP ranges, and not have to manually check an application and report that back to us. But what we were able to do is empower the developers to raise pull requests against that and just have security and networks potentially approve that. But there's more smarts in here than just getting ranges. We're able to say, hey, what subnets do you want within that range? You want a web and an app and a data? Okay, that's cool. Let's take advantage of some of the inbuilt Terraform functionality, like the CIDR subnet breakdown function, within our module to automatically create those for you and loop through those subnet names that you've given us to define and build that for you, so that you as a developer potentially don't need to know and have a huge background in networking. So that can really accelerate how we go from having absolutely nothing to getting through to the end of it. So what do these benefits look like? So the problem statement that we had at the start was really that we've got all these things that we expect developers to do in the current world. We've got infrastructure, security, risk and compliance, networking that we touched on, but we've also got operational requirements and cost management concerns that we need to do. And what I see happening over and over and over again is we start to push all these pressures down onto the developer. And really what they're trying to do is just develop and deploy their application. And hopefully they're getting involved in some of our DevOps processes as well. But mainly we want them to, really contribute to their business logic. So how does something like Terraform Enterprise actually solve that with all the things that we've spoken about? So when we look at something like this, we've got all of a sudden, with all of the modules that we've created and defined, we've got different roles and different people contributing to the area that they have the IP in. So all of a sudden we have the DevOps guys contributing to infrastructure. We have security engineers potentially writing Azure policy, or maybe it's Sentinel policy to fix our security needs. We have network operation engineers helping us with our connectivity issues, and potentially even risk people getting involved with that process. And by pulling all of those modules into something like Terraform Enterprise, Terraform Cloud, or even baking that through open source if you really wanted to, we're able to get these benefits that we have on the left. We're able to get that reusability, cost visibility. We increase our governance and compliance because we're getting more people involved. But the productivity that we get is so much more increased because of these activities. So what we're able to do is this developer can now just focus on the development and the deployment of their application, because they're feeding off the definitions that we've done as a collective through our inner source module and really following our GitOps approach. And that really does lead to the faster delivery times, the quicker innovation times, and if you like, even the unlocking the ability to leave your data center and go to the cloud faster, which has been my experience when we're looking at implementing these things. So there's some other features within Terraform Enterprise that are really important to touch on. And as a matter of fact, Kyle Ruddy, who, it blew me away with his presentation earlier today, has a really good session. So if you haven't had a watch of that, please go and have a look at his on-demand session. There's some amazing demos in there about some of the things I talk about. But Sentinel, for those that don't know, really is a policy as code framework. And it works with our enterprise offerings for some of the products and Terraform Cloud as well. But it can be used for everything from SIS benchmarks to security controls, tagging, even identity management if you really want to push it that far. And one of the great resources that Kyle talks about is the Terraform Foundational Policies Library. That's a GitHub repo, which is an amazing resource to get started really quickly and even just have a look at how we can use Sentinel in a best practice way. But so some of the use cases we've used, and Kyle touched on this as well, is tagging, especially in Azure, is critical. You're crazy if we don't tag things, and it's crucial for things such as cost code, cost management, even relating things back to CMDB IDs, if that's what we need to do for certain organizations. But if we look at doing those potentially natively within Azure, we end up defining or auditing or even denying those after the deployment's attempted to happen. And for some things, if you deny, that might stop something scaling out. So if we have a virtual machine and that needs to scale, but it's denied because it doesn't have tags, well, then our scale is going to fail. And that's a big problem. So Terraform will stop those issues happening by having the detection happen before the deployment. What we also did was it enabled us to continue thinking about that in a one-to-many way. So originally we attempted to try to put all of these validation rules inside each module. We quickly realized that if we could use Sentinel to have a single point of management for all of the deployments that we do, it was all managed from one place. So it really released us from that operational overhead that we were getting ourselves trapped into before. So it's a really powerful tool. And actually, in one of the examples that I've got here, we actually used it to break down an access problem that we had. So when we look at root access issues, it's been around for a really long time. We just call them different things. If we look at Solaris jails, preventing things from touching root, we can, this diagram applies to that as well. What we want to do is enable developers to touch certain things but not others. So how do we manage that? Well, we could use Sentinel to whitelist Terraform modules, for example, that have very specific instructions on how we want to deploy those. And that can be a really powerful tool, because what we can do then in something like Azure, where we don't have the ability to use Azure forests and organizational units like we do in a traditional on-premise environment, we're able to abstract the identity provider and the RBAC control away from each other. And that's a really powerful concept that we can start to leverage in amazing ways to enable developer productivity, but also increase our security posture, which is fantastic. That's really Sentinel, but Sentinel's the glue that really holds some of these things together. And to be honest, some of the deployments I've done for Terraform and Enterprise, we couldn't have done it without Sentinel as a tool and using that policy engine to get us over the line for some of the controls we had to do. But to just touch on the responsibility model again, hopefully through this you can see that we've moved through traditional IT, hybrid IT to cloud native IT. So now that we've got all this module, this intellectual property, we've got collaborative work, we're using Terraform Enterprise and Terraform to reuse our IP, we can get everyone on the same page in our way of working and get everyone collaborating in a specific workflow. And that really enables us to use more cloud native technologies like functions as a service and containers and all the things we want to play with. But it also removes the barrier to entry for people to start having conversations about improvements. We're actually enabling innovation to happen. And it actually reduces the cost of changing anything as well, because everyone's across and on the same page. So it's a really powerful motivator to try to unlock the value of cloud that we have. That's really all I wanted to talk about really today in terms of GitOps and how it unlocks cloud. I'd like to thank Cam, who's the Staff Solutions Engineer in APAC here for HashiCorp, for being in the questions and helping out. He's an amazing resource. So reach out to him on Twitter if you've got any questions. A couple of links here to get started. There's the HashiCorp link to Terraform there where you can download and get started. An article I've written before about similar topics. And then if you have any other questions after that, reach out to me on the mediums that are there. But apart from that, I think I'm going to go to bed soon. It's about midnight here. But thanks to the sponsors for HashiConf and thanks to the community team for bringing together an absolutely amazing event in a couple of months. It's amazing to see the platform you've got. And thanks very much for having me.